All right, this is problem number 2 on page 251 of our related rates problems, and it reads, the radius r and the surface area S of a sphere are related by the equation S equals 4 pi r squared. So they give us that equation. It might be kind of nice they gave us that equation. You may not have known that one. So the surface area of a sphere is 4 pi r squared. Write an equation that relates ds dt, the change in the surface area, to the change in the radius. And again, we check this out. We've got our surface area, we've got our radius, and look at that. They gave us the equation with the surface area and the radius in it. So any related rates problem, we're going to take the derivative. We're going to take the derivative with respect to time. And if you watched the first video, I apologize, this is redundant. But when we take a derivative with respect to time, then you realize if the variable is not time, but some other variable, then we just write that as ds dt. Oops, that could certainly still be uppercase. And the only time it wouldn't be is if you take the derivative with respect to time, and it is time, if it's the same letter, then that truly is, that derivative is 1. But anything else, if the letters don't match up, we'll get a ds dt, a dr dt, or whatever the letter happens to be, unless it's t. So our surface area is 4 pi r squared. We'll take the derivative with respect to time. We're taking it to both sides. And the left side I get ds dt. Those are different letters. That's the surface area. That's time. So it's just ds dt. And on the right side, I've got my 4. I've got my pi. Those are constants. Constants connected with multiplication. So they factor through. I've got my 4 pi. And now the derivative of r squared gives me, I'll bring down as a power. I'll bring the power down. I'll make it 1 less, so it's r to the first. And then again, it was r squared, so I brought down the power, I made it 1 less. And now I take the derivative of the inside, because of the chain rule, and the derivative of the inside gives me dr dt. If I rearrange this slightly, I get ds dt equals 8 pi r dr dt. And we now have an equation that relates ds dt to dr dt. And that completes our problem.